Hello, students. We're here back on Monday for our first full week back, albeit in the online format. Today we'll be having our Zoom call at our regular class. We'll do it for as long as necessary, but up to an hour. You notice that I also put some spreadsheet examples for you on announcements, how to build out your cost-benefit spreadsheets for when we're doing our reazes. Okay, it's likely that that may form a discussion during our Zoom call today, because I expect that students will have questions about how to set out their values or how to estimate them and so on. So that's what I expect that we'll focus on our Zoom call today. I advise students not to be missing those calls, because I will be marking attendance for them. And even if the calls don't require a full hour, that's your opportunity to ask questions and to get them resolved so you can complete your project and ultimately, of course, graduate. So let's look today at the question of summative statistics of cost-benefit analysis, discounting values to the baseline, which will be our main emphasis for today's lecture, obviously. Okay. So discounting, what is it? When we're considering future costs and benefits of an investment, a discount rate is needed to bring all values back to a common unit of measurement in the baseline year. We've discussed this before, right? We do realize that $100 today is not $100 a year from now. So we apply a discount rate such that future costs and benefits are brought back to the same units of measurement we've used in our baseline. All right. So, and because, as you know, in all forms of economic analysis, we're always comparing the future cash flows to the reality that would have been the case at the baseline year. All right. So keep that fully in mind as we work through this project. Okay. So, I mean, calculating interest is essentially the opposite of discounting. To calculate the value of something over time, normally the following formula would be used. Okay, you can see that on our slides in slide 4. V bracket 1 plus 1 times T is essentially the interest rate we're looking at. So $100 times 1 plus at 8% interest equals $108, and so on. And you would calculate that over a 7-year period in the example I'm giving in your slides. And you can see that in Table 1, a simple interest calculation in Table 1. Now, interest is not a difficult concept, but then again, discount is simply the opposite of interest, so that's not a particularly difficult concept either. Okay, so calculating a discounted cost of return. How much would you have to put in the bank now to get $100 after 1 year with an interest rate of 8%? Here you can see the formula that I provide on slide 6. In our example, we need to put $92.60 in the bank now to achieve US $100 over 1 year at an interest rate of 8%. Okay, so that's fairly straightforward. But then you could calculate that over many years if you want to. Obviously, the formula that you would use, you could do it by hand, of course, but the formula you would use will be provided in Excel, as I will be showing to you in a little bit. Okay. Now, discounting rate. What do we use for our discount? We used 8% in these examples, but clearly interest is not 8% now. It's not the type of interest rate we're dealing with today. So particularly now with COVID-19. So we need to come up with our answer as to what discount rate to use. And I'm going to give you that discount rate. It's an evolving question for me, but I'm changing that discount rate. Let's deal with it at 5%. So everybody can use a 5% discount rates. Okay, and most governments, by the way, do preset their discount rates. And the reason they preset their discount rates, for example, if you're doing a contract with the government, they may in fact give you a discount rate if you're doing cost-benefit analysis, because they would like to see a standard discount rate used across government proposals for expenditures. And the only way to adequately compare the best use of scarce resources to minimize opportunity costs is to compare investment options that have been using the similar forms of calculation, and in particular the discount rate. Now, typically, we would also do a sensitivity analysis with the discount rate. For example, we would run one at 5%, we might run one at 6%, we might run at 4%, just to see what the implications of the discount rate are for our calculations, because even a small change in the discount rate, especially if a project extends over many years, can have a very significant impact on the NPV at the baseline year. So typically we will run some scenarios with different discount rates. And you'll see when we look at the Excel, YouTube examples, and so on discounting, that this is not a difficult thing. The main thing is to get all your cash flows in place. And the rate that you discount that is a very simple change within a formula, and Excel will do it for you. Okay, so do run some different discount rates. Use a 5, maybe a 6 or a 7, and a 4 or a 3, just to look at whether there's a great deal of sensitivity in your cost-benefit analysis results. But typically what I want you to report on is a 5% discount rate. All right, so let's work on that basis. You can see in slide 8 that I provide you with one example of discounting in a YouTube video, but there's more at the back. I mean, one of them might be repetitive, but there's more at the back that I give you so that you have more opportunity to understand, in fact, how that should be done. Okay, so we'll probably deal with that in our Zoom call. All right. Now, what type of analysis, what type of statistics are you going to be ending up with? Obviously, one of the simple ones is benefit cost ratio. The BCR is the ratio of the benefits of the project or proposal expressed in monetary terms relative to its costs also expressed in monetary terms. Net present value, which you'll learn how to calculate in Excel, involves converting all future costs and benefits related to a project or proposal into present values. Subtracting the present values of all costs from the present values of all benefits gives you the net present value of the project, or the NPV. Now Excel will do all of that for you. Okay, calculating the benefit cost ratio and the NPV require a discount rate in order to bring all values back to the baseline or present values that will be invested. We just talked about that. Okay, I'm asking you to use a 5% discount rate. Everybody should use that, but then depending upon the nature of your project, run some risk assessments on that discount rate just to see what would happen if we calculated it at 4% instead of 5, or 6% instead of 5. I just want you to see what the implications of that is to your final cost-benefit ratio and your NPV. All right. Calculating NPV, determine your initial investment or your investments throughout various periods of the years you're looking at a regulation. Determine the time period to analyze. That should be at least 10 years for each one of your projects, at least 10 years. If there's major technological investments required, and those technological investments you anticipate might have a turnover rate of 20 years, then use 20 years, okay? But at least use 10 years, okay? Estimate your cash inflow for each time period. Those are benefits, okay? Determine the appropriate discount rate, which is 5%. Discount your cash flows, which we'll show you in Excel. Sum your discounted cash flows and subtract your initial investment, or your investments that may be phased out over 5 or 6 years. All right. So that's the key for calculating your final NPV. All right. So I say in slide 11, you can see again how NPV and IRR in Excel are calculated. Follow that very clearly. It's a very simple formula. It's very easy to follow. What's the difficult part is reaching your estimates of your costs and benefits for each year going out at least 10 years. And for year 1, cost minus benefits gives you a cash flow for that year. Year 2, cost minus benefits gives you a cash flow for that year. That's what we want, and you'll see that in the Excel templates that I'm giving you. Okay. Typical summative statistics used in investment decisions are also some other ones, some internal rate of return and return on investment. The IRR, you'll see in some of the videos that I'm giving you. It's easy to calculate IRR. All I'm looking for from you is cost-benefit ratio, NPV, and IRR. Okay, but there are many other subtypes of summative statistics that will be used in cost-benefit analysis. Okay, and in slide 13, I take you through ROI. IRR, on the other hand, because it's different. Our ROI is different from NPV and IRR because it doesn't require discounting, whereas we want discounting in NPV and IRR, and you'll see that in the YouTube videos as well. Okay. So I give you some verbal instructions in slide 15, but again, go over the videos. The videos are very clear as to how to calculate NPV and IRR in Excel. Okay. One thing I encourage students to be careful with is do not fall into the payback period trap. Payback period can be useful for cash flow analysis, but it's not particularly useful for the type of analysis that we're doing in terms of looking at the overall cost-benefit implications of a regulation over probably a minimum of 10 years. All right? But you need to be aware of payback period in any case. Payback period is essentially if you buy a piece of equipment, how long will it take that equipment to be paid back? That's not a very useful statistics for cost-benefit analysis, but it is for cash flow analysis. For example, say we bought something, we were spending $2,000 a month to pay for it. Our cash flow of that $2,000 a month is occupied until that item is paid off. Then at the payoff date, we can consider other investments. That's the cash flow analysis, okay? For a cost-benefit analysis, we don't want payback period because let's look at an example of buying a car. Your first 5 years, that car is costing you a lot of money. Your payback period is the same month of the 5th year that you bought it, say April. 5 years hence, your payments are over. Does that mean you stop calculating the benefits of the car? Of course not. The car doesn't really even start paying you handsomely until it's paid off. Then you're driving a car essentially only for gas and maintenance costs. And it starts to return you a lot of benefits at that point. First 5 years you were getting benefits, but it was against a cash flow of monthly costs, okay, or yearly costs, and which meant that your summative column, your costs minus benefits, was looking pretty weak. By the time you get to year 6, your costs are very low, your benefits are very high, your cash flow is looking very positive. Okay, so that's why we don't use payback period for this type of analysis. In slide 17, you have a number of different things. Some of these may be repetitive, but I wanted you to see them again and look at them, okay? I also have one article there. When projects have a 0 or negative NPV, read that article. It's quite a good article summing up what to consider when we look at that, okay? So that's it. Go through the videos. Don't forget to go through the video series on cost-benefit analysis by the Conservation Society, which I've further posted for you. That's a very good summative set of 13 or 14 videos that take you all the way through cost-benefit analysis. And it's a good thing to view in any case because it gives you a much better understanding of cost-benefit analysis than we would have time to in this course because it's a dedicated course to just cost-benefit analysis. Okay, so go through that. I've gone through it many times. It's a very good series. I really encourage you to take the time to go through it all to fully understand what cost benefit is. Okay, so I'll be talking to you all at 4 o'clock this afternoon in our Zoom call. All right, talk to you soon. Bye-bye now.